Hi, my name is Matt Kosovec, CEO and co-founder of DataForge, and today we're going to be looking at the newest features in DataForge and do an extended demo and walkthrough of the new capabilities around conversational interfaces, comparing it to other solutions such as the Databricks Genie, and finally showcasing capabilities that are unique to DataForge and the ability to add and change platforms after you've already built them and have used generative AI solutions to create them. Let's jump right in. Quick review of the agenda. We're first going to define the problem. Then we're going to look at a developer workflow that you would need to run through or work through without DataForge. We're then going to do an extended demo of building an end-to-end lakehouse in DataForge using a conversational interface. Next up, we're going to look at Genie, some of the limitations, how Databricks Genie and DataForge Talos AI can work together to solve complex business problems. And then finally, for steps 6 and 7 here, we're going to look at adding logic to an existing platform, what that workflow looks like without DataForge, and how DataForge helps to solve that challenge as well. Lastly, we'll talk about a wrap up and next steps. So let's jump right into the problem here. We're looking at a prompt, which is a request from the business. This could be from a finance group or operations. In this case, it's probably around sales because it's asking to build a report around ordered quantity, discount, subtotal, tax freight, total due, sliceable by order date, order number, store product, and country region code. Our existing setup within our cloud environment or within our infrastructure, it looks like this. On the right-hand side, we have an empty lakehouse. We've got nothing built in it. We've signed up for Databricks and we've set the networking correctly. However, we don't have anything built, no tables, no infrastructure, nothing is set up. On the left-hand side is going to be our source data. This is going to be an application database. It's a SQL server. This would be the backend for maybe your ERP or your solution that runs your organization. And again, this will have data for finance information, operational data, manufacturing, if you're in a manufacturing space, so on and so forth. The tricky part is that it's spread out over 70 different tables. For a non-technical user looking to extract this data and analyze it correctly, navigating these 70 tables is going to be really difficult. They have a complex data model that's buried into the back end of the application, and allowing and having a non-technical user be able to work with this data without a large amount of expertise around that back end is what we're going to solve for today. So with that, let's look at the developer workflow for building a solution without using AI or any other automation tools as part of the development cycle. Who needs to do this work and what the overall timeline and cost looks like. So here's a 5-step process of what would be required in order to bring the data from that source system into the lakehouse and design a solution that then enables easier analysis by an end user. Our goal is to take some subset of those 70 tables and transform them into either a single table or maybe 1 or 2 tables that then allow the end user to do this analysis and have this report displayed to them without them having to understand all the complexities of that source system model. So really quickly running through here, we have the first step, which is system discovery and exploration. First, they need to go look at those 70 tables and understand what or which tables and columns within those tables are needed in order to produce this result. Next up, we do need to copy that data from that source system into the lakehouse, into that cloud environment in order to begin processing it and doing these following steps. Steps 3 and 4 are all about 2 things. First, this change data capture and incremental loads. This ensures that it's not just a one-time question and answer solution. We're building a data set that is useful over and over again across multiple contexts or multiple prompts. This data set will be refreshed on a regular basis. And because it's refreshed on a regular basis, we have to build extra logic around what's called change data capture and incremental loading. The next step is going to be data enrichment, quality checks, cleansing, and consolidation. This is going to be looking at the specific data elements, making sure that in order to get to this final result for this prompt, we are looking at any anomalies or erroneous information within the data and fixing that up as part of the processing, as part of the movement from that source system to that target table that we're using for the model. Both of these are oftentimes, steps 3 and 4 are oftentimes custom for every single table that you're working with and is coded by hand. The final piece here is going to be target data model definition. This is figuring out exactly how to structure the data in its final form so that it can be easily used by a non-technical individual to do an analysis reporting, or a different structure. For example, instead of analysis and reporting, maybe you're building a separate structure for feeding into an AI model for evaluation or feature engineering, or maybe you're setting data up for batch inference. And finally, of course, with new large language models, maybe you're staging data up for embedding and vectorizing data, which is related to large language models, and customizing your own Gen AI solution. All of these things need to be defined and built and designed. This end-to-end process is conservatively can take 5 weeks, which with a data engineer who on average in the US costs $160,000 a year, could easily be $15,000 to build. And this would be on a per report basis. Just building this from scratch is actually the easiest thing to do. Later on this video, we'll talk about the workflow to add logic to an existing platform. All right, now that we've walked through that really long-winded workflow of all the things a data engineer needs to do in order to set up, build, and manage a Lakehouse solution, let's look at how DataForge can help automate it all and implement a conversational interface on top of all of that to allow non-technical users to do the same work. So just quickly looking at what we'll be building in the next few minutes here, we're going to be building a solution to bring the data from those 70 tables or a subset of them, identify which ones we need, land them into the raw layer, stage them up into the stage layer, put them into this hub layer, and finally publish them to this final data warehouse layer, all within the Lakehouse, all using best practices and medallion architecture and all of these things that are standards within the industry today, and your smart engineers or architects would be implementing by hand. This is all driven by user prompts in a conversational interface that DataForge then interprets, confirms what the user is asking it to build, and then automates the entire development of the Lakehouse technology within modern solutions such as Databricks, AWS, Azure, GCP, etc. All right, enough context setting and enough defining how big the problem is and how painful it can be. Let's show how easy it is for a non-technical user to build an end-to-end Lakehouse solution with Talos's and DataForge's conversational interface. All right, so here we are. This is the Talos conversational interface that lives within DataForge. We're going to take the exact prompt that we were asked to create, build a report including these measures, metrics, and columns, and we're going to see how Talos can walk us through the process. And this is why we talk about Talos as a conversational interface. It's not meant to be just prompt generate code. It's meant to help you refine your requests and help you bring context and information to you so that you can better define exactly what you need, what you're trying to build within this specific solution. So in this case, the first thing it did is it scanned all the connections, all the tables that are available to DataForge, which is a layer on top of Databricks, which is a layer on top of AWS, Azure, GCP. And it has identified that, hey, for this specific request, you likely want to use this system, this AdventureWorks 2019. And this is correct. It correctly identified AdventureWorks 2019. This is going to be those 70 tables in that SQL server that we need to leverage in order to build this report accurately. Once I've told it exactly what connection to use, it's going to now search all the tables, columns, and metadata in that connection to build a data model and match my prompt to specific columns that are available in that source system. So taking a quick look here on the left-hand side, this is our prompt decomposed into specific requests that it then matched to specific columns that are available in the source system. So if I look closely, it did a good job. It said, hey, for store, you likely want the name from the store table, so on and so forth. However, I'm looking more closely here and it looks like order number isn't exactly right. It looks like it grabbed purchase order number, which in this context, I don't think is really what I need. I'm not exactly sure what I need. I think there's something better out there. So rather than purchase order number, I'm going to ask Talos to rematch order number, and it's going to perform a new search, simply excluding purchase order number from the potential results. Another thing while it's working is it didn't just naively grab data from all of these specific tables on the match tables. It's also looking at the source system data model and how the different tables are connected in the application, and then deciding that in order to build a final report that uses all of these columns correctly, we're going to need to bring in a couple other tables as intermediary connections between these tables that have the matching columns that I requested. So now that I've, again, going to scan through, make sure everything's looking good, everything looks accurate, I'm going to ask it to create sources and pull data. You can see it says, would you like to proceed creating sources or would you like to make any adjustments? Again, there's a bunch of other tools such as adding columns, rematching, re-inputting the prompt, adjusting things along the way. But in this case, we're going to keep things moving, and I'm going to ask it to create sources and pull data. When I talk about sources, this is DataForge lingo for pipelines. So I'm asking it to create 8 pipelines, 5 for the tables that are matched with my prompt, and 3 for these intermediary tables. It's correctly now created 8 of these sources and identified that all of these are going to be new sources that were previously completely, were not built before. You can also click through to each one of these and see more detail. So for example, sales order detail, I can quickly jump into the developer interface if needed. And here we have all kinds of, logic and lower level views into what's happening under the hood. There's an entire data model I mentioned that's available under the hood here. But again, as a non-technical user, maybe I don't want to get overwhelmed with all of that extra information. I'm just going to ask Talos to help me understand a bit more about what was just created. So I'm going to say, please give me a detailed description of the customer source, which would be number 4 here, right? So I have specific interest. Maybe, again, I want to just make sure that everything that's coming in from the customer table is looking good, and that the parameters around how that pipeline was built are exactly to my specifications. So by giving this prompt, I can, again, get more information, and this can be done at any time, right? I could have asked more information around the tables that it matched with, but now that we're working in a pipeline, it's going to give me specific information about not only the table and the columns that are in that table, there's some descriptions about what those specific columns mean, but it's going to give me parameters and information around the pipeline that was built. So here you can see it's going to land the data in a Lakehouse table called customer. It's going to be refreshed. In this case, our default here is once a year. In a production environment, this would be maybe once a day or every 15 minutes. It's set up for incremental refresh. It's using a key, which is customer ID, in order to perform that incremental refresh, so on and so forth. Again, there's even more stuff under the hood here, but this is the most relevant information for most users, just to quickly scan and make sure that what was built by Talos through the automation is done correctly. You could also tell it live in Talos to make adjustments here. For example, hey, I want the refresh schedule to be nightly. Again, all of that is doable with a quick prompt. But for the purposes of this demo, we're going to keep moving. The next thing it's asking us is, would you like to create an output? So going back quickly to our workflow, everything we've done so far is steps 1 through 4. The first thing was refining exactly what tables our prompt was asking for and what columns specifically. That was number 1. Again, knocked that out pretty quickly. Steps 2 through 4 were all handled with that last prompt, which was create the sources. When it created these eight different tables and 8 different pipelines, it knocked out all 3 of these very complex, oftentimes very manually developed and customized stages of ingestion, change data capture, data enrichment, quality checks. The final step here, number 5, is what we're going to be doing next. So it's asking us, do you want to create an output from these sources? And this is going to design and build a target data model based off the context that we want to use this data for reporting. So I'm going to say, yes, please build, please create an output. It's going to take the context of these 8 tables and the data model that was taken from all of the different source system metadata and all those different structures and modeling based off our prompt, and it's going to create a final target table. And so here it goes. It says, hey, the output sales report has been successfully created. Now we're going to take a look at the developer interface quickly, because for outputs, it's a little bit more simple and less overwhelming. So let's open up this next. And I'm going to go over to the mapping screen. Again, this just shows how, even though we're looking at the developer interface, it's not super complicated. You're not looking at hundreds of lines of code. On the left-hand side, it has decided, based off of our prompt, that we need to get rows from two different tables, sales order detail and sales order header. And then the columns for this table are going to be across the top here, right? So for each one of these across the top are going to be columns in the table that is ultimately going to combine all the information from these 8 different tables into this one result. And so you can see there's some mappings here. Some of the data is straight coming from sales order detail, sales order header. Other data is leveraging that data model on the back end to join the data together and produce these final results. So with that, you've seen now how we've worked through all steps 1 through 5 to build everything from the source system to the target, easily and quickly within DataForge, within the Talos AI user interface. Now that we've shown how quickly it is to build all of the different solutions within DataForge, let's look at what actually was created within Databricks and how easy it is to use. So we're still in the DataForge user interface. We're going to be looking at the sales report output. Again, I could use Talos for this, but I find it helpful just to look directly here. It looks like it's going to publish data to a sales report table in Unity Catalog. So let's click through into Databricks. We're going from our solution DataForge down into Databricks to then see exactly how this information is stored and how we can then access it with tools within DataForge or other BI analytics and capabilities that work natively with DataForge. One of them with Databricks, one of the most popular and well-distributed platforms today. So if I look here, you can see we now have our sales report table. Sales report has all the columns that we had defined and all the data to combine this different 8 tables together. It's now loading and executing a query to showcase, yes, all the data that we need to. Rather than it being those 8 tables, it's now in one central table and is all correct and accurate and display. And this table is structured in a way that if you run some summarizations or aggregates or plug in a BI tool such as Power BI or Tableau or other analytics tools, it will aggregate this data correctly without duplication and get the results that a non-technical user is expecting. Okay, so quick review of our agenda and where we are. We just completed building an entire lakehouse with DataForge. It wasn't just a source to target. It had all the intermediary bells and whistles for a enterprise-grade lakehouse. Next up, we're going to look at the Databricks Genie, some of the limitations it has, and then how the Databricks Genie and DataForge can work together. So as we worked before, we were in the Databricks interface. I'm now into their Genie solution. Genie is the name of their conversational interface that is focused on BI development. BI is all about visualizations and analysis on top of data sets. So rather than focusing on building all the pipelines, it's just focusing on producing visualizations and analysis on top of existing data sets. So let's see how trying to do the same thing in Genie as we did in DataForge hits some snags and then how they work together. So I'm going to go through here, and this is the setup for a Genie space. A Genie space is a specific context or a specific group of tables, as well as a name and some descriptions and some helpers that then allows the Genie to analyze and work with that specific portion of your data model or portion of your tables. So rather than Genie being able to search the hundreds or potentially thousands of tables that are available to Databricks and or DataForge, as a user, I have to specify exactly what tables I want to use and for Genie to look at. So I'm going to look here and we're going to go to the same AdventureWorks SQL. I'm going to have to figure out which one of these many systems I want to access. I know, based off of the context, okay, we've already kind of worked through that. I also know I probably want to do sales. There's this whole process now around me identifying a specific subset of tables in order to bring everything together or bring everything in or have Genie look at everything. And you can see this is a confusing process. Like, I don't need this. I think I need this. I'm not sure. I'm going to also go to person and grab a couple things out of here. this would typically be quickly going back into the context here, right? Everything we're doing is around number one, right? So this number one week-long process, I'd have to look at every single one of these tables I'm checkboxing and try to guess at, hey, do I need this specific table in order to answer this specific question? If yes, I'll do number two, or if yes, I'll try to figure out where to go from there. So again, this is a very manual process, a very guesstimation process, if you will. So I think this is good on person, and I think I want production too, product category. I think that's pretty much it. Okay. So I'm gonna hit confirm. I'm gonna click save. Great. Now it's important to note that there's a hard limit on the number of tables that Genie can look at a time. Even the reason I didn't checkbox everything within the AdventureWorks database, all 70 tables, is because Genie will not allow you to look at more than 25 tables. And there's a good reason for that. So what we're going to do here is give the exact same prompt that we asked Talos to help with and ask Genie. And again, I will give the context that we're really showcasing where the limits of Genie are today. It's not really meant to do this. We're just really highlighting this to showcase how Genie and Talos can work together to automate the entire end-to-end solution. They're both focused on different things and therefore complementary to each other. So by giving it the same exact prompt, you can see it does give us a result, which is pretty great. And if we go into the code, it is able to correctly identify how to connect everything together. It gives us, the hookups between the different entities. However, the real challenge here is you can see there's actually a lot of data duplication. So you see there's rows here that even though they have different product names, for example, they have data duplication for total rows, freight, tax amount, subtotal, etc. And we got lucky this case because it was able to correctly identify the joins between these different tables through inference. However, it's not using the more sophisticated tools within Talos to look at the source system data model and then make these joins exactly accurately based off of that data model. And the result of that, and not looking at and understanding that data model in context of building these queries, is that, again, we have a report that if I were to then build a visualization, such as, let's see, summarize or visualize, if I can type, visualize total due by region. Unfortunately, by doing this process, it's going to give us results that are just kind of crazy. And the reason these results are just kind of crazy and it's not doing a great job is because of this data duplication and because of what are ultimately bad joins. And it's simply because BI Genie or the Genie within Databricks was not meant to do this. It doesn't have all the context. It doesn't have all the information or the structures within the DataForge framework in order to put this data all together and model it correctly for this result. It's expecting the data to already be modeled correctly, for everything to already be consolidated and cleansed. This is meant to be a final layer of a user interface for a non-technical user to build charts and reports on an already curated modeled data set. So let's take a look at how much improved the result is if we leverage the result that was created by Talos and by DataForge. So I'm going to create a new space, Talos Genie. And instead of selecting all of those source tables, all those tables from the source system, I'm going to ask it to just look at the sales report table that we created by combining all those tables using Talos. And I'm going to give it the same question. I'm going to say visualize, again, if I can get it, visualize total due by region. And it should give us a better result. There we go. Rather than doing something crazy with a pie chart that's hard to look at, because the data now is modeled correctly, the DataForge Genie knows exactly what to do whenever I ask this very generic, very broad question, and comes up with a great visualization around what's the total due, which is revenue in this case, per region across the entire data set we're looking at. I could further refine this by trying to break it down by year, doing other analysis, and that's where Genie really shines, is allowing, again, users or developers to look at visualizations and then refine and look at and analyze the data. Talos and DataForge is focused on creating these beautiful data sets that then enable these downstream capabilities. And again, here we're looking at the Databricks Genie, that again is a conversational interface for BI, which is where a lot of the market is going. Where the future really will be is integrating directly, where Genie is able to identify, hey, the question you've asked me, I don't really have a great data set or a great data model to support that question. I'm going to go ask Talos to please build a data set that can answer this question. The Genie then asks Talos. Talos does all the magic we talked about before, potentially prompting Genie to ask the end user to refine their request to make sure that everything is working correctly, as you saw in the earlier workflow. And then finally, it will respond and put everything together for the end user to produce this same report, but without having to jump between tools and without having to jump between conversational interfaces. Okay, the final part of our demo here is to solve what is actually the hardest part of any data lakehouse build. It's not building the initial thing, it's adding to it over time. And this is a problem that's across every other solution. Even the best technologies and platforms that are built with developers by hand still have this challenge and must be developed with this type of workflow. Let's quickly run through it. So for example, it's asking us to just add a column, a calculated column to that data set that DataForge created, that sales report data set that Genie was able to work with super well. We just want to add one more column called product lifetime. And it's a date calculation to try and figure out, basically how long was this product on sale, start date, discontinue date, and end date are all factored into it. Let's take a look at really quickly at the developer workflow in order to add this single column to a target table. First, they'll have to look at the existing system, the same discovery process of, is all the data I need in order to create this calculated column available in the system already? Or do I need to go get that data from a different table or a different source, or do I need to query a new column from an existing table that I'm already processing? All of that needs to happen first. It can get really, really complex and expensive when you have, again, thousands of things already built and maybe tens of thousands of tables available for you to explore and discover. The next up is code change design and impact analysis. Once you've kind of determined where and what you need to look at all the existing code. And again, this could be tens of thousands of lines of code, and figure out not only where to make the change in order to add this calculation and persist that calculation all the way through to the target table, but predict how that change may break a bunch of other stuff. And that can be, again, also very time consuming and very risky. The next two steps are really all about testing and then refining the final solution. By making one small change, you may again impact many different things in the solution. And so you must test not only the thing you changed, but all those things you may impact. And then finally, this reorchestrate performance test, it's not just about the logic, it's also about the infrastructure. By adding a single table, by adding a single column or a single join, you may dramatically change the performance characteristics, meaning you need a lot more compute or a lot more storage or a lot more something in order for everything to work correctly. Or by adding this bit of logic, you've introduced a dependency to say, first I need to calculate this table, then I need to calculate this table, so on and so forth. That's a whole, again, separate process and manual design workflow for an engineer that scales exponentially with the number of pipelines and tables that are already in the system. So as you can see, we have multiple things that basically, as the system gets bigger and bigger, this gets longer and longer. It can get way out of control when you have a system with hundreds of thousands of pipelines in operation and you just want to make one tweak. Finally, it's not just about getting the code out there, but now you need to make sure you run manual processes to do what's called backfill. So when you add a new column to a target table, because it's not just a one-off, it's a live pipeline, you need to run a manual step to say, hey, for every single row, for every single incremental load that was ever done, I need to recalculate and reprocess this once so that this new column is populated. Again, this is all stuff that is bread and butter for data engineers to work through. However, it's extremely time consuming and tedious for them to do this. And as you can see, a lot of this is manual, therefore error prone. You're highly reliant on them checking everything that they need to and not making any mistakes along the way. So you can see even more expensive, even though we're just adding one column rather than creating a report with 100 columns even, it can oftentimes be easier to add a whole new report rather than just add a column to an existing report. So you can see this is even more expensive. All right, enough doom and gloom about how bad things are today and how difficult it is to work with other solutions and add new columns to existing tables. Let's see how easy it is to do with Talos and DataForge. So I'm going to put in the exact same prompt that we saw, that long-winded workflow. And now Talos is going to understand, based off our prompt, where exactly to add this code, make this change, and how to potentially restructure the entire platform and solution based off of this addition. So it took the first half of this and it understood exactly where to make the change. And then the second half of this of exactly how to calculate it. So this was able to generate SQL. Again, this is just Spark SQL in this case, because we're working with Databricks. And we can now jump into the developer interface just to validate this. It's compiling this code to make sure, in the context of everything else in the platform, this code will run correctly before we even save it into the system. But as you can see, it's all good. I'm going to click save. Now that it's saved, I can quickly jump over to, here and click recalculate. And now that it's recalculating, we can see, right, it's going to queue up a run. It's going to reprocess this data, backfill everything effectively, and then populate the target table as needed. The second thing we need to do is in our final report, we're going to need to add the target column. The first step we did there was add the column in the calculation to the pipeline. Now we need to tell it, hey, take the result of that pipeline calculation and publish it to our final destination here. So I'm, again, just going to highlight, we could do this in Talos, but I like to highlight the developer interface a little bit in every demo. So let's call this product lifetime, just to show how easy it is, even if a non-technical user can work in here, no problem. We now go to product, lifetime, boom. Now that this mapping is completed, this will be correctly identified as a new column in this target table. And the next time that sales order detail is run, it will detect that because there's a new column, it'll automatically run a backfill operation, meaning everything you see here, steps 3, 4, and 5 were all done automatically. The regression testing, performance testing, everything was adjusted based off of metadata and information we have within the DataForge environment about how this change adds additional load or changes dependencies or would cause backfill. Everything is deterministic and easy for us to detect, and therefore we can make the associated adjustments to the existing solution and the Lakehouse pipelines to do what needs to be done so that at the end of the day, that target table has the new column and is populated correctly. This is the power of the DataForge framework, which then is the Talos UI and Talos Conversational interface working together to automate the entire Lakehouse build, operations, and management. We've only scratched the surface. We looked through 2 workflows of well over 100 workflows that we support within the DataForge environment. And we can't wait to hear from you about what specific challenges do you have? What things take a long time in your world for a Lakehouse to build, manage, and operate? And we'd love to talk to you about how DataForge can help you optimize those processes or automate them entirely, and how we can get non-technical users closer to the data and also combine things like Talos with BI solutions, with AI solutions, with large language models, so that they can all agentically interact and communicate, so that the entire lifecycle of Lakehouses, data, end use cases, complex AI solutions can be handled elegantly and effectively. Thank you so much for your attention today, and look forward to connecting.